Tree diagram is a simple way to list all possible outcomes of an experiment. In other words, to list the sample space of an experiment. When we are figuring out probability, thinking about probability, in most cases, we need to figure out how many total possible outcomes we have, because definition of probability is number of favorable outcomes divided by number of total possible outcomes. So we need to find number of favorable outcomes and we need to find out total possible outcomes. So tree diagram helps us create the sample space. Here's an example. If a couple decides to have 4 children, find the probability of 2 boys and 2 girls. So for 4 children, we can go ahead and use the tree diagram and start. The first child can be a boy or a girl. The second child can be a boy or a girl. And the third child can be a boy or a girl. Lastly, the fourth child can be a boy or a girl. Make sure you give yourself enough room because, as you can see, it does take up a lot of space to come up with the tree diagram. This is called a tree diagram. And how do we get the sample space out of it? So elements of my sample space will be boy, 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 girl, boy, boy, girl, boy, 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 girl, girl, boy, girl, boy, 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 girl, boy, girl, boy, girl, girl, boy, boy, girl, 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 boy, 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 girl, boy, boy, girl, girl, boy, girl, boy, girl, boy, nope, girl, girl, boy, boy, girl, 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 boy, boy, girl, girl, boy, girl. Girl, 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 boy, girl, 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 girl. So started with all 4 boys to all 4 girls. We have all the possibilities in between. So for this problem, we wanted to find out probability of having 2 boys and 2 girls. It doesn't matter in which order. So out of the 4 children, there's 2 boys and 2 girls. We want to find probability of 2 boys and 2 girls. And I listed the sample space right below. We can see over here the 2 boys, 2 girls are, these are the possible cases where we have 2 boys and 2 girls. So total number of possibilities here is 16. And so probability of 2 boys and 2 girls out of 4 children will be 16 will be the denominator, total number of possibilities, and out of there, 6 is the favorable number of favorable cases. And we can go ahead and simplify, divide both numerator and denominator with a 2. That comes out to be 3/8. That's the probability. We can also express the probability in terms of a decimal, rounded to 4th decimal place. Reduced fraction is perfectly fine. Next example is Venn diagram. So we have this Venn diagram where we have set A, B, and C is the larger set, or the outside box. That's the total thing. We can call it the set C. Probability of A will be all the elements in the A. Looks like in A we have 15 and 3 divided by the total possibilities. So 18 in the A, and the total we have 15 plus 3 plus 8 plus 4. 3 are the ones which are in both A and B. 15 are just in A, not in B. 8 are just in B, not in A. And 4 is not in A or B. 4 is outside. Okay, so probability of A would be 18 out of the total possibilities. Total possibilities will be 15 plus 3 plus 8 plus 4, which turns out to be 30. Probability of A prime means everything other than the A elements. Everything which is not in A is 12 out of 30. And I'm not reducing the fractions, but we can go ahead reduce the fraction to simplify our answer. Probability of B, the elements in B, is 8 plus 3, which is 11 out of 30. B prime is everything else other than the ones in B, and that's going to be 15 plus 4, which is 19 out of 30. Probability of A union B. A union B will be, let's see, A union B is everything in A and B together, but we're only going to count each once. So that is going to be 15 plus 8 plus 3 is 11. So the intersection, we cannot count it twice. A union B means every element which is a part of A or a part of B. We don't want to count the intersection twice. So 15 plus 3 plus 8, which is going to be 26 divided by 30. Probability of A intersection B. Intersection means the ones which are common in both, and that's going to be 3 divided by 30. Again, we will reduce the fraction and simplify the fraction. Probability of A prime intersection B. So A prime intersection B means elements common between B and A prime. So what elements are common between B and not in A? That would be, so elements in B but not in A prime, or a complement. This line on the top means complement or prime. A complement and B. So everything in B but not in A, that's going to be 8 out of 30. Last one, we have probability of A prime union B prime. So A prime union B prime would be everything that is not in A union everything that is not in B. So everything that is not in A or everything that is not in B, in that case, we wouldn't count the intersection of these, we will count all of the rest of the elements. So we'll count the 15 and 8 and 4 and not count the intersection of these. So 15 plus 8 plus 4, that would be, plus 4 is 12, plus 15 is 27 divided by 30. That's all for this video.